Okay, this lesson will focus on the law of sines, or is commonly called the sine rule. And this applies to non-right angle triangles. So what we're looking at are non-right angle triangles. So far, we've been looking at right angle triangles. And in a right angle triangle, one of the angles is 90 degrees. Now, a non-right angle triangle, known as oblique triangle, none of the angles are 90 degrees. So we cannot use the Pythagorean theorem, nor one of the trig ratios to find an angular missing sine. So therefore, we focus on the sine rule. So our goal today, which is lesson 7, is to use the law of sine, or the sine rule, to solve for an unknown side. So today we focus on finding the unknown side. The next lesson will find the unknown angles. So just to recap, so triangles that do not have a right angles are called oblique triangles. And therefore we can't use the same trig ratios. So here's an example of an oblique triangle. We have one of the angles 105 degrees. And the angle is labeled with a large letter. So we label this angle C. The side opposite is labeled small c. So they're matching letters, but one is a lowercase and the angle is uppercase. Same as we have angle A. So this would be side A, small letter. And this is angle B. This will be side B. So we can say this is side C, side A, and side B. Now, what you go about, you should just ask yourself, when you have a triangle, is it a right angle triangle? And if the answer is yes, we go straight to the Pythagorean theorem or SOHCAHTOA. So far, we've been using the Pythagorean theorem, which is c squared equal a squared plus b squared, and SOHCAHTOA, which is the sine, cosine, and tangent ratios. Now, if it's not a right angle triangle, we have to use the law of sines, and there's another rule known as the cosine rule, the law of cosine. Now, when we can't use either, if it's the law of sine or the Pythagorean or the SOHCAHTOA, we have to use the law of cosine. Now, what does the law of sine looks like? Now, as I look at the previous one, the law of sine. Now here we have a triangle, and A, B, and C, the small letters, are the sides. So we can label this as side. These are the sides. And these are the angles. So you have angle A, angle B, and angle C. Now the sine law, we can write it in two ways, which is sine of angle A. So we can put an angle here. So this refers to angle A is equal to side A. Or sine angle A, B, sorry, sine angle B is equal to side B. Or side angle C over side C. We could also flip it over and label it differently. And I'll show you why it may be an advantage to have the side label listed at the top. So we have side A over sine angle A, side B over sine angle B, and side C over side angle C. So they are related, just they're ratios of use angle over side or side over angle. Now, at any time when we're solving equations, we only will use one pair of these, one set. There are three pairs here. We have side over angle, side over angles. So we're going to use one pair at a time, one set. We can use two sets of ratio here, B over side B or C over side C, or A over side A and B over side B. Or we can use A over side A and side A, B, C over side C. Well, when we work through a few examples, it will come to life. So we can simplify the law of sine. By this rule here, we have the law of sine is A over sine A, B over sine B, C over sine C, sine C. And therefore, this is angle. So let's look at some examples from your booklet. So let's look at the first one, using the law of sine to find an unknown length. So we'll be referring to our sine rule frequently. So we'll find a match. So first step we'll do, step one, we will label the triangle, label the side and the angle. So step one, label the angles and the sides. So one hint, whenever we're labeling it, the unknown, I always try to list one of the what you're finding as the A, either the side or the angle. In this case, we need to find the side. So we'll use this side A over angle A, side B over sine angle B. So I need to find this angle here, so I'll label this as A. So this will be side A. This will be angle B, side B. Now we can complete the labeling. This will be side C, small c. So step two, we write down what's given. So given and what we need to find. So we are given angle A, which is 62 degrees. We're given angle B, which is 43 degrees. And we're given side A, or sorry, side B, which is 26 feet. And you're asked to find side A. So now we go straight to our sine rule and find what we'll use, since we're trying to find side A, we will use this pair of ratios. We use side A over sine angle A, side B over sine angle B. So step number three, I use sine rule. And I write mine. So we have side A. I'll just be more explicit for now. Later on, I will not indicate the side, but the side A over sine A side B over sine angle B. Then I substitute the given value into my equation. So we have A, we don't know, so we call it X. Sine angle A, so sine 62 degrees equal side B, which is 26 over sine angle B sine 43. Now we can do our cross multiplication and or for algebra. So one way we can do this is, it's a longer way, but it works. So we can do cross multiplication. I'll show you there's a shorter, a different logical way of doing it, but for now I'll show you for many of you are familiar with cross multiplication. So we have X sine 43 degrees and sine, so 26 sine 62. Now I need to get rid of the sine 43. So I divide by sine 43 degrees. So sine 43 divided by sine 43 is 1. So I'm left with X is equal to 26 sine 62 sine 43. Then I'll have to go to my calculator. Make sure you're in degree mode. Which I am. So I enter exactly what I see here in my calculator. So I have 26, so X is equal to 26 sine 62. So 26 sine 62. And I will press enter just to get, so on top here it's 22.956. Then sine 43, 0.681. So I do everything in one here. So I divide this. So by sine 43. So I'll do it all in one, and you can do the same thing in the calculator, but I would suggest you put brackets around these when you're completing them. So for example, I'll start off with a bracket here, 26 sine 62, close bracket, I'll put a double close bracket there, divided by open bracket, sine 43. And that will give me an answer of 33.66. So 33.66 feet. So X, in this case using the sine law, is 33.66 feet. Okay, just to recap, we're using the law of sines, known as the cosine, or known as the sine rule. Step 1, we label the angles and the sides of the oblique triangle. Then we write down what's given and what we need to find. Then we go to our sine rule, write it down, and then substitute the given values into the sine rule. And we always use just a pair of ratios, equivalent ratios. And we have sine B over sine and angle. So always a side, you can have the side over the angle, side over the angle. They have to be consistent. You cannot flip these around. They will not match. You could also have written it as angle over side. But because we need to find the side, we want the unknown, which is we need to find as enumerated. So that's example 1. Let's look at example 2. So as I mentioned, step 1, we're asked to find for x. So step 1, just rewrite it here. Step 1, label angles and sides. So since we are finding a side, I always label, or the easiest way to label the angle opposite the unknown side as A. So this is my side here I need to find. So label this side as A. You don't have to, but it makes your calculation much simpler, or it seems to be more obvious. So this will be side A. And the next, I'll label side B. This be, angle B. This would be side B. Angle C, side C. So step 2, write down what's given and what's need to be found. So we're given angle A, angle B, side B. I mean, define side A, which is equal to x. Step 3, we'll write our sine rule. So sine rule would be A over sine A, B over sine B. Then I substitute the given values into the sine rule formula. So we have A, we don't know, we call it x. Sine 35 degrees is equal to B, the 6 over sine 76 degrees. You can continue your cross multiplication, but remember another easier way of doing this is that here, we'll put it here, x over sine 35 is equal to 46 over sine 76. So I need the x to be by itself. So I need to move sine 35 from the left to the right. So I multiply by its reciprocal, which is sine 35. So sine 35, so I'm going to do exactly that on the opposite side. So sine 35 divided by sine 35 is 1. So I'm left with x is equal to 46 sine 35 over sine 76. You can also do the cross multiplication and you result will be the same. So we can continue from here. We have x is equal to 4 to 6 sine over sine 10 to 6. Then I'll go my trusted calculator here. Put that on. So it's 4 to 6. So x is equal to sine 35, which is 26.384516. And we have sine 10 to 6 to 0.97029. Now, I just record these to show you what the values look like. Notice the sine of the angle can never be more than 1. So if you notice you have sine and it's greater than 1, check your calculation. It's not correct. So I'll do all of this in 1 because we don't want to round. This is rounding here. So we'll have an approximate figure if we put these numbers down. We'll be pretty close. So what I would suggest, you do this exactly in a calculator as all in 1. So normally you put a bracket around these with a division. So the way you do this in a calculator, you put the bracket first, and just 4 to 6 sine 35, close bracket, divided by open bracket, sine 10 to 6. And gives me a result of, so x is equal to 27.19, and our measurement is meters. So we can write this as 27.19. So we highlight that. By the way, if the question that asks you what's the missing angle here, we'll use the rule, the 180 rule. But in this case, it did not. Okay, let's go on to the final example, 3. Now, this is a tricky one because we'll follow through with a few things and see what's missing here. So step 1, label the angles, sides. So this is our unknown side. We label this as angle A. And the match just set is given with angle B. It's be angle C. But notice what happens. We don't know the angle here. There's a missing match. We need a pair. We need one of these two here. We could have used this part here, and then we'll find, and we could find side C, but they're not asking us to find side C. They're asking you to find X, which is in our label here, opposite of angle A. So notice, what's the 180 rule? The 180 rule states that if we know 2 angles, we can find a third one by subtracting these 2 known angles from 180. So we have to use, so put a note here. Use the 180 degrees rule to find angle A. So angle A will be equal to 180 degrees minus 80 minus 29. So angle A, in this case, equal to 71 degrees. So 71 degrees. So now we have all three angles. So step 2, we write down what's given. And what's given, now we have angle A, 71 degrees. We have angle B, which is 29 degrees. And we have side B, which is 52 centimeters. And he has to find, this be side A, which is X. Then we apply our sine A over sine A, B over sine B. Substitute our given values. We have A, we don't know, that's X over sine 71 is equal to 52, which is P here, over sine 29. So just remember, we can do our algebra here, 71 or cross multiplication. So multiply this by sine 71, multiply by sine 71, becomes 1. So we have X is equal to 52 sine 71 divided by, should be sine here, sine 29. Then we go to our trusted calculator, because we can't do this without our trusted calculator. So we'll do that right now. So we have open bracket 52 sine 71 close bracket divided by sine 29. So give me a measurement of 101.42. Well, it's 41. So X is 101.41 centimeters. So X is 101.41 cm. So we'll highlight that. Okay, so that's your third example. Your task is to complete questions 1, 2, and 3. So right here, assignment. Page 19, question 1, 2, and 3. So let's recap. We use the law of sines, or the sine rule, for triangles that are not right angle to find either a missing side or a missing angle. And the sine law can be written in two ways. Sine A over side A, sine angle B over side B, or sine angle C over side C, or we reverse the ratio side over angle, side over angle. In our examples today, we looked at finding the unknown side length. And the first step we do is to label the side and the angles that right down was given. Then we use one of the sine rules, ratios. And we remember we only use two of these ratios at a time, the equivalent ratios. So far, we focused mainly on making it simpler by looking at sine. Because we need to find the side, we make sure our side is as a numerator in our ratio.